Hello everyone. As we already discussed about the quadrilateral, today we are talking about some of the properties of quadrilateral. So the properties can be based on length of the sides of any quadrilateral, and it can be based on the angles in the quadrilateral. So the first property is, when we join the midpoints of all sides of a quadrilateral, what figure it will form. Suppose we have a quadrilateral ABCD. Any of the quadrilateral. Suppose this is the midpoint of AB, this is the midpoint of BC, again this is the midpoint of CD, and this is the midpoint of AD, and we are joining all the midpoints of any quadrilateral. Then the figure EFGH is what kind of quadrilateral? So here the most important theorem is the midpoint theorem. One thing we have to understand clearly, that whenever we use the term midpoints in any of the quadrilateral, so we have to look for the midpoint theorem. Here we know that in a triangle ADB, if we talk about a triangle ADB, and we know that H and E are the midpoints of AD and AB, then definitely HE is parallel to DB and HE is half of the length of DB. So HE, the value of HE is equal to half the value of DB. Same way, if we look at the triangle DBC, then F and G are the midpoints of DC and BC. Definitely this line is parallel to this line as well as half of it. So when HE is also half of DB, which is in front equal to GF, so we can say HE and GF are both equal in length. Same way, if we divide the quadrilateral ABCD into two parts by joining AC, then HG must be equals to half of AC by the concept of midpoint theorem, as well as this is equals to EF. So HE, G and EF both are equal. And if in case we know that EF is equals to GH and GF is equals to HE and they are parallel to each other, definitely they will form a parallelogram. This figure EFGH is a parallelogram. Now the second thing is, if in case we join the midpoints of a rhombus or we join the midpoints of a rectangle. So this is a rhombus. The property of rhombus is that the diagonal bisect at right angle to each other. Then if we join the midpoints of this rhombus, it will form a rectangle, because all the four angles at the corner must be 90 degree. On the other hand, if there is a rectangle and we are joining the midpoints of a rectangle, they will form the rhombus, where all the sides of this quadrilateral must be equal. So this is basically rhombus. So we can say, if we join the midpoints of rhombus, it will form a rectangle, and if we join the midpoints of rectangle, they will form a rhombus. So these are according to the sides. Now the second is according to the angles. Suppose it is given that AD and CD are two parallel lines and there is a transversal passing through the point E and F. If in case we go for the bisector of the angles which are internal angles, here we know that angle AEF is equals to angle EFE. And if we are going for the bisector, then we know that these two angles are equal and these two angles are equal. Same way, angle EFC, this complete angle, is equals to angle FEB, this angle. And this must be equal to each other. So if in case we know that the total angle on a straight line is 180 degree, it is very clear that this angle plus this angle will be half of 180 degree and it will come out to be 90 degree. So the angle FGE is also 90 degree. Same way we can say that this angle plus this angle is 90 degree. So the angle EHF is also 90 degree, and once we know that these angles are 90 degree, these are also 90 degree, so it is forming a rectangle. This is another property that the bisector of interior angles of a parallelogram encloses what figure? Now, we can take a parallelogram which is considered to be ABCD. If in case we go for the bisector of this angle and bisector of this angle, these are the two lines which will be going like this. If we take the bisector of this angle and the bisector of this angle, again these are the two lines which will go like this. Now the point is the sum of this angle plus this angle is 180 degree. So half of this angle and half of this angle will amount to 90 degree, which will assure that this point E will make a 90 degree angle with A and D. And if this is a 90 degree angle, then the angle opposite to this is also a 90 degree angle. So the form means the figure which is enclosed, which can be termed as EFGH, inside a parallelogram, this will be a rectangle. So if the bisector of interior angles of parallelogram is a figure is enclosed in it, so this figure EFGH will be a rectangle. So these are the properties of a quadrilateral, and after this we will go for the next topic, that is circles.